In question 1, we have molten lead at its melting temperature of 327 degrees C poured into an iron mould where it solidifies. The temperature of the iron mould rises from 27 to 84 degrees C, at which point the mould is in thermal equilibrium with the now solid lead. We're given the mass of lead at 1.20 kilograms, the specific latent heat of fusion of lead at 2.5 times 10 to the 4 joules per kilogram, the mass of the iron mould is 3 kilograms, and the specific heat capacity of iron is 440 joules per kilogram per Kelvin. In A, we need to find the heat energy absorbed by the iron mould. Well, energy is given by mass times specific heat capacity times temperature change, which for the mould we have a mass of 3 kilograms, a specific heat capacity of 440 joules per kilogram, and it goes to 84 from 27 degrees C. An interval of a degree C is the same as that of a Kelvin. This comes out at 75240 joules. This is 7.5 times 10 to the 4 joules to two significant figures. In B, we need to find the heat energy given out by the lead while changing state. Well, for this we've got the heat energy is given by the mass times the latent heat of fusion, which is 1.2 kilograms of lead, and this is the latent heat of fusion given in the question, gives 3.0 times 10 to the 4 joules. For C, we need to find the specific heat capacity of the lead. Well, this is given by the energy transferred over the mass and the temperature change. The energy transferred is the energy which has been received by the iron mould minus the energy which was given out during fusion of the iron. The rest of the energy must have come from the cooling of the solid iron. Here we have the mass and the temperature change going from 327 degrees C to 84 degrees C. This comes out at 154 joules per kilogram per Kelvin. In D, we need to state one reason why the answer to part C is only an approximation. Well, this calculation assumes all the energy lost from the lead goes to the mould. Some of the energy will be lost to the surroundings.